The adrenal gland, it can be pretty complex, right? Because it functions like two glands in one, right? It's cortex and the medulla. They're very different. It's sometimes called the suprarenal gland because it sits above the kidney, right? Supra means above, renal refers to the kidney. And the adrenal gland shares a capsule with the kidney, which I think is strange, right? Like, why would you want to be this really important gland, the adrenal gland, and then be exposed to all of this toxic waste in the kidney potentially? So the adrenal gland, it's got a 3D pyramid shape, but when you look at it through 2D histological slides, it usually just looks like a big triangle, mushy triangle. The gland consists of an outer cortex, which is fatty, made of lots of cholesterol, and then an inner medulla. Right? We said the cortex has this striped appearance in diagrams from that zona fasciculata, while the medulla contains a whole lot of blood vessels and neurons that you can see here. The hypothalamus connects directly to the adrenal medulla through neurons. And the medulla, it's composed of like specialized neurons that are called chromaffin cells. And these are the cells that release epinephrine and norepinephrine and a little tiny bit of dopamine. These hormones, all three of them, collectively known as catecholamines, are distributed throughout the body by way of blood vessels from the medulla, and it provokes a general sympathetic fight or flight response. Stress perception begins in the hypothalamus. And the hypothalamus has a direct neural connection to the adrenal medulla, kind of like this connection. It's not exactly accurate, but it'll do it for us here. This connection, this direct connection, it enables the medulla to release epinephrine and norepinephrine by way of action potentials, right? It's an action potential that's triggering the adrenal medulla to release these hormones. These hormones, they circulate throughout your body and they target specific organs to prepare them for the like immediate action of running away from a threat. So the heart beats faster and with greater force. Blood vessels constrict to redirect blood to skeletal muscles. And bronchioles in your trachea, they dilate to allow more oxygen intake as you are running away from the threat. While you're running away from the threat. Catecholamines are not just about mobilizing you, but they're also about preserving glucose for two things: responding to that threat and preserving enough energy for the brain while you do that. So the threat could be many things. It could be real, it could be hypothetical, and sometimes just the thought of a stressful situation can evoke these effects, culminating in a very real panic attack. Very real. First, there's this process called gluconeogenesis, which we will see again. And it's this process of creating glucose from non-carbohydrate sources, like fatty acids, like triglycerides from your adipose deposits, right? And this, it ensures that there's a backup supply of glucose, even when dietary intake is low or even when it's been used. The next thing is glycogenolysis. And this is where glycogen, which is stored in the liver, is broken down into glucose and released into the bloodstream. Insulin does the same thing that that these catecholamines do. They all do glycogenolysis. So together, these processes can create a larger supply of ATP for running away and thinking. Additionally, there's this glucose sparing effect, which is shared with growth hormone. And what it does is it directs other tissues, like muscles, to rely on fats for energy instead of relying on glucose. And this spares the glucose, specifically for the brain, ensuring that the brain has enough ATP in these like critical moments. So beyond reserving glucose, the body also ramps up its readiness for action It increases respiratory rate, ensuring more oxygen is available. It increases the heart rate and circulation to get that oxygen to the skeletal muscles. And it increases providing nutrients and oxygen to the muscles so they can help you run away from the threat, not your muscles individually. So there's also a shutdown of things. We don't just mobilize things with these catecholamines. We shut down processes such as digestion and urine creation. And these are pretty much halted for a short-term stress response, conserving available energy for organs that can contribute more in responding to the threat. You do not need to generate urine in responding to a threat. You do not need to digest your food while you are running away from a threat.